Hello and welcome to The Light, the channel that illuminates the greatest minds in history. Today we're journeying back to the 17th century to explore the life of a man who reshaped our understanding of the universe, the one and only Sir Isaac Newton. Get ready, because his story is more than just an apple falling from a tree. It's a tale of relentless curiosity, brilliant discoveries, and a legacy that continues to shape our world. Born prematurely on Christmas Day in 1642 in a small village in England, Newton's early life was far from auspicious. His father died before he was born, and his mother remarried, leaving young Isaac in the care of his grandmother. In 1661, Newton enrolled at Trinity College, Cambridge. It was here that his insatiable mind truly began to flourish. He devoured the works of ancient philosophers and contemporary thinkers, from Aristotle to Descartes. But he wasn't just a passive reader. He was a critical thinker, constantly questioning and building upon the ideas he encountered. He filled notebooks with his own thoughts and queries, exploring everything from light and color to the infinite. Then, in 1665, a historic event changed everything. The Great Plague swept through England, forcing Cambridge to close its doors. Newton returned to his family home at Woolsthorpe Manor for what would become his Annus Mirabilis, or Year of Wonders. Imagine being sent home from college for 2 years, and in that time, laying the groundwork for calculus, revolutionizing our understanding of light, and formulating the law of universal gravitation. That's exactly what Newton did. It was during this period of intense, isolated thought that the famous apple incident is said to have occurred. Now, the apple probably didn't bonk him directly on the head, but seeing it fall did spark a profound question in his mind. If the force of gravity could pull an apple to the ground, could that same force extend all the way to the moon, keeping it in its orbit around the Earth? This wasn't just a fleeting thought. It was a revolutionary leap in scientific reasoning. He connected the terrestrial with the celestial, proposing that the same physical laws govern everything in the universe. But gravity wasn't his only focus. Newton was also fascinated by light. At the time, the common belief was that white light was pure and that prisms added color to it. Newton, through a series of brilliant experiments, proved the opposite. He used a prism to split sunlight into its constituent colors, the familiar rainbow of red, orange, yellow, green, blue, indigo, and violet. Then, in a stroke of genius, he used a second prism to recombine those colors back into white light. This simple yet elegant experiment demonstrated conclusively that white light is not pure, but is, in fact, a mixture of all the colors of the spectrum. This discovery laid the foundation for the entire field of optics. After Cambridge reopened, Newton returned and was soon appointed the Lucasian Professor of Mathematics, a prestigious position he would hold for over 30 years. It was during this time that he consolidated his work. However, he was famously secretive and reluctant to publish his findings, partly due to a fear of criticism. It took the persistence of his friend, the astronomer Edmund Halley, the man Halley's comet is named after, to convince him to share his monumental discoveries with the world. Halley not only persuaded Newton, but also financed the publication of his work. In 1687, the world of science was changed forever, with the publication of Philosophiae Naturalis Principia Mathematica, or simply, the Principia. This masterpiece is widely regarded as one of the most important scientific books ever written. In it, Newton laid out his 3 laws of motion, which form the bedrock of classical mechanics. Let's quickly recap them. The first law, the law of inertia, states that an object will remain at rest or in uniform motion unless acted upon by an external force. Think about it. A soccer ball won't move until you kick it. The second law explains the relationship between force, mass, and acceleration, summed up in the famous equation F equals ma. A harder kick makes the ball go faster. And the third law states that for every action, there's an equal and opposite reaction. When you kick the ball, your foot feels the impact just as the ball does. These laws, combined with his law of universal gravitation, provided a complete mathematical framework for describing the motion of objects on Earth and in the heavens. For the first time, humanity could accurately predict the orbits of planets, the path of a cannonball, and the ebb and flow of tides. Newton had, in essence, written the rulebook for the universe. The Principia was a triumph of reason and observation, and it established Newton as the preeminent scientist of his era. Later in life, Newton's focus shifted from pure science to public service. He moved to London, became warden, and later master of the Royal Mint, where he reformed the nation's currency and pursued counterfeiters with the same rigor he applied to his scientific investigations. He was also elected president of the Royal Society, a position he held until his death, and in 1705, he was knighted by Queen Anne, becoming Sir Isaac Newton. He wasn't just a scientist locked away in a lab. He was an influential public figure who left an indelible mark on British society. Newton's legacy is almost impossible to overstate. He provided the tools and the framework that scientists would use for the next 2 centuries. His work propelled the scientific revolution and paved the way for the Industrial Revolution, even Einstein's theory of relativity, which later refined our understanding of gravity in extreme conditions, stands on the shoulders of the giant that was Isaac Newton. He showed us that the universe is not a chaotic, mysterious place, but an orderly system governed by precise, discoverable laws. He taught us to question, to experiment, and to believe in the power of the human mind to comprehend the cosmos. Sir Isaac Newton passed away in 1727 and was buried with honors in Westminster Abbey. His epitaph beautifully captures his essence: mortals, rejoice that there has existed such and so great an ornament of the human race. From a quiet boy tinkering with models, to the man who unveiled the mechanics of the universe, Newton's life is a powerful testament to the limitless potential of human curiosity. He didn't just see an apple fall. He saw the universe in motion. Thank you for joining us on The Light as we explore the incredible life of Sir Isaac Newton. If you found this journey as fascinating as we did, please hit that like button, subscribe to our channel, and ring the notification bell so you don't miss our next illumination of a brilliant mind. We'll see you in the next video.